This is Carrie Reinhardt with 5-Minute Math. I am finishing up the section on special products, specifically sum and difference of cubes today. If you're following along in the book, it's from Algebra 2, Unit 1, Lesson 3. So we already looked at sum and difference of squares, and we looked at the perfect square trinomial. But for this video, I'm looking at sum and difference of cubes. This one is easy to spot, just like the sum and difference of squares. Okay. The perfect square trinomial is a little bit harder to spot, but the sum and difference of cubes is easier. You've got a perfect cube, a cubed, plus or minus another perfect cube, let's say b cubed. So for example, we could have x cubed plus 8, because x cubed is a perfect square, and so is perfect cube, and so is 8. When I say perfect cube, I mean 2 cubed is 2 times 2 times 2, which equals 8. That means 8 is a perfect cube. Okay, 1 is a perfect cube because 1 times 1 times 1 is 1. 27 is a perfect cube because 3 times 3 times 3 is 27. So knowing those perfect cubes does make this a little bit easier to spot. But the formula that it factors into is a plus or minus b, so the sign in the original stays the same for that first part, times a squared minus plus. That means that the sign switches. So if it was addition here, it's going to be subtraction here. Okay, that's what that symbol means. All right, AB, and then plus b squared. Okay, so the first sign is the same, the second sign is the opposite, and this last one is always positive. So we use the phrase SOAP. That means same for this first one, opposite for the second one, and then always positive for that last sign. So to factor this one right here, what I first do is find the cube root of each of them. So I'm going to find the cube root of that and the cube root of that, which the cube root of x cubed is just x, and the cube root of 8, as we saw a minute ago, is 2. So now I can factor it. So that's going to be x, and it's going to be plus because it's the same here, 2. And then I need this squared, so that's x squared. Now I need to do the opposite sign, so the opposite is minus in this case. Then I've got to do a times b, so x times 2 would be 2x. And then plus, because this is always positive, and I need to do b squared, which is this square. 2 times 2 is 4. And then this would be your final answer. And again, you can always check these by distributing. Remember, x times x squared is x cubed. X times negative 2x would be negative 2x squared. X times 4 would be 4x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And then 2 times 4 is 8. And what happens here, you've got a negative 2x squared and a positive 2x squared cancels. A positive 4x and a negative 4x cancels. And you'll notice you're just left with that x cubed plus 8, which is what we started with to begin with. So we know we factored it correctly. All right, let me do one more example here. All right, so let's say that we have 27m cubed minus x to the 6th. And I know this doesn't quite look like perfect cubes, but they are, okay? Because 27 is a perfect cubed, and so is m cubed. The cube root of those is 3m. Okay? And then the cube root of x to the 6th is x squared, because x squared times x squared times x squared is x to the 6th. So if its power is a multiple of 3, then it is a cube root. So now I need to go ahead and factor this. So the first part is the same sign, so it's minus. I'm going to go ahead and put my signs in. The second sign is the opposite, so it's plus, and then the last one is always positive. Well, this is A and this is B, so we've got 3m minus x squared here. This next part is a squared, so I've got to multiply this by itself. 3m times 3m, which is 9m squared. The next part is a times b, so I've got to multiply 3m times x squared. So that's just 3mx squared. And then the last part is b squared, so I've got to multiply x squared by itself. So x squared times x squared would give me x to the 4th. And this is what it would factor into.